Hi, welcome back to the massive open online course of MAT 522. In this video, we will look at the classifications of the differential equations. The first classifications that we considered here is the types of the differential equation. Generally, there are two different types, namely the ordinary differential equations, ODE, involves only ordinary derivatives, and partial differential equation, PDE, that takes account the partial derivatives in it. Now, essentially, in this course, we only consider ODE in our study and learn the methods to solve them. Second classification, the order. The order of a differential equation means the highest derivative in it. In the first example here, we can easily observe that d squared y over dx squared is the highest derivative in this equation. Therefore, this is a second order ODE. As for the second example here, take note that y triple prime is the highest derivative. Therefore, this equation is the third order ODE. Simply as that. Third classification corresponds to the degree. Now, the degree of a differential equation is the exponent of the highest derivative. Be careful with the keywords here, the exponent of the highest derivative. As in the first example here, the highest derivative is the d squared y over dx squared. This term has the exponent of 1. Therefore, this differential equation has degree 1. Well, it should be easily recognized that the second example here, y double prime, is the highest derivative that has exponent 2. Therefore, this equation has degree 2. Last classification is with respect to linearity. To decide whether a differential equation is either linear or nonlinear, we can observe the following three properties. First, the dependent variable and all its derivatives should be of degree 1. Second, no product involving dependent variable and its derivative. Finally, there should be no nonlinear functions in the differential equation involving dependent variable. Now, we can easily see that the three examples given here are all linear differential equations. For example, if we look at the middle equation, d squared y over dx squared, this has degree 1. dy over dx is also of degree 1. Y, dependent variable, also has exponent 1. There is no product involving y and y prime. There is no nonlinear function. Therefore, this differential equation is linear. The other two examples can be verified in the similar way. Now, whichever differential equation that fails to satisfy either one of the three properties, then we claim that this differential equation is nonlinear. In other words, there is at least one dependent variable and its derivative of higher degree, that is bigger than 1. Or there is at least a product involving dependent variable and its derivatives. Or there exist nonlinear functions in dependent variable. For example, here, the first d squared y over dx squared minus 5y squared equals to exponent x, we can easily see that the dependent variable y here has higher degree of 2. Therefore, this differential equation is nonlinear. For the second example here, if you can detect it, exponent y, there is nonlinear function in the dependent variable. So therefore, this differential equation is also nonlinear. Finally, in the third example here, one can easily see that there is a product of y and y prime in this differential equation. Therefore, this is nonlinear. Now, I would like to draw your attention one more time is that in the definitions of nonlinear differential equation, we only consider dependent variable. Regardless of how independent variable x behave, that doesn't affect the declaration of linearity. That's it for the second video. See you next.